Living on other planets has been a dream to many space fanatics and sci-fi moviegoers for years. Ever since the first astronauts touched down on the moon in 1969, we have wondered what could be next in our space exploration. Even today, there are many ideas for sending people to space for tours or creating space hotels. However, the real mission that has been in discussion for some time is how we could someday sustain life on other planets, and scientists have recently discovered something new that just might aid us in making this dream a reality. When it comes to the logistics for colonizing other planets, such as Mars, there are many factors that we have to consider and work to find solutions for. These include everyday necessities for life to flourish, such as gases, the atmosphere, exposure to cosmic radiation, soil contents for growing food, access to water, and many other factors we do not have a great amount of control over. One aspect scientists have discussed is how to efficiently build structures for housing and provide shelter from the harsh environments on other planets. The issue they are facing here is the time and price it would take to send building materials into space from Earth. Just a single brick alone would cost up to $2 million. To solve this problem, astronauts must be flexible in using what little resources they have readily available on other planets. Scientists believe they have found a possible solution to this problem, but it calls for astronauts to put in a large amount of blood, sweat, and tears, literally. Researchers at the University of Manchester in England have developed a method of creating concrete using dirt and dust found on the surface of Mars, along with proteins that are found in human blood plasma. They have named this new development Astrocrete. Scientists have been trying to develop viable technologies to produce concrete-like materials on the surface of Mars, but we never stopped to think that the answer might be inside us all along, says Aled Roberts, the study's lead author. Human serum albumin, HAS, is a common protein that can be extracted from human blood samples. It was discovered that these proteins, when combined with Martian soil, creates a biocomposite that is just as strong as normal concrete. The strength of concretes are measured in megapascals or MPa, while the compressive strength of normal concrete can range from 20 to 32 MPa. These biocomposites were found to have a strength of 25 MPa. Not only that, but the strength of these biocomposites can be increased greatly by incorporating urea that is found in human urine, sweat, or tears. It was found that by incorporating urea in their mixtures, scientists are able to create a biocomposite with a compressive strength of 39.7 MPa. This is much stronger than regular concrete alone. Strength and stability are important factors to consider, as Martian dust storms can create wind speed over 100 km per hour or 62 miles per hour. Using blood for construction is not a completely new process, however. In medieval times, animal blood was commonly used as a binder for mortar during construction, making structures that were stronger and longer lasting. Furthermore, scientists believe they can create these exotic biocomposites in space through the use of a 3D printer, making colonization for future astronauts much easier and faster. This could also allow for the production of complex shapes and parts with internal support structures to be used during construction. This process would require regular, weekly blood collections from astronauts, so the effects of this, along with every other stressor they would be experiencing from traveling to and living on Mars, must still be researched further. It is believed that a 6-astronaut crew could create more than 500 kilograms, or about 1,102 pounds, of this Astrocrete during a 2-year mission, which would be used to create housing to support other astronauts and further continue the process. So far, this is the leading technique of all those proposed for colonizing Mars in the future. There is still uncertainty in this method as scientists continue to experiment and understand the limits of using HSA for biocomposites on Mars. Even if this method is found to be unviable for construction on Mars, it is still an important example of how astronauts can use what little supplies they have on hand, where out-of-the-box ideas can be used to solve a problem. Whenever it comes to being alone, millions of miles away on an uninhabited planet in space, it is this type of ingenuity that can be used during life-threatening emergencies to save the lives of those working to colonize Mars. However, if this is a feasible method for construction in space, we should be one step closer to the future of living on Mars. That is all for our video today. Thanks for watching. If you learned something new or found interest in today's video, let us know in the comments section below. Also, if you haven't already, please subscribe to our channel and don't forget to hit that bell icon so you will be notified of all our newest uploads. We will be back very soon. Until then, take care.